Magnets come in different sizes and shapes. Many of these different shaped magnets you must have seen in your daily life. There are many things that differentiate magnets from each other. Shape, size, and material they are made up of are just a few such things. But do they tell us anything about the strength of the magnet? Let's find that out. We'll talk about the size of the magnet first. Suppose we take a smaller bar magnet and a larger bar magnet. They both have the same shape. Assume that they're both made up of same material and are identical in every aspect except size. What do you think which of these two magnets will be stronger? Yes, your intuition is correct. The bigger magnet will indeed be stronger. For instance, if you keep an iron nail at a certain distance from each magnet, then the bigger one will apply more force on the nail than the smaller one. Note that this is true because the magnets are identical in every other aspect. Size is the only difference. Now consider the two bar magnets with similar shape and size except that they are made up of different materials. This one is made up of alnico and this one is made up of neodymium. Which of them do you think will be stronger? Yes, the one that's made up of neodymium will be stronger. If you remember, these two are the materials that are used to make two different types of permanent magnets. We know that neodymium magnets are stronger than alnico magnets. So far we've seen that the strength of a magnet depends on the size of the magnet and the materials of a magnet. The third thing it depends on is the shape of a magnet. Yes, the shape of a magnet. There is a purpose behind making magnets of different shapes and they're not just made up of artistic reasons. Shape of a magnet is one of the important factors that defines the strength of a magnet. Bar magnet is the simplest shape of a magnet that each one of you might have seen. However, did you know that it's the weakest shaped magnet of all? Yes, for instance, a horseshoe magnet of same size and same material is considerably much stronger than the bar magnet. Why so? Compare the magnet with the bar magnet. You see that the horseshoe magnet has both its poles on the same side, while a bar magnet has them on opposite sides. So how does it make a difference? If you bring a piece of iron near one of the poles of a bar magnet, then this pole will apply the force on the iron piece. If you now bring the same piece near one of the poles of the horseshoe magnet, then it will again exert attractive force on it. But since the other pole is near this one on the same side, it also exerts the attractive force on the iron piece. So did you get the difference? The strength of the magnetic field created by the horseshoe magnet near the poles is greater than the strength of the magnetic field created near the pole of a bar magnet. So in one way, the horseshoe magnet is an advancement over the bar magnet. Similarly, the other differently shaped magnets with greater pole area are made so as to increase the magnetic powers of a magnet.